Sometimes in math, whenever we have statements of congruency, we also have implicit double ratios. Now I want y'all to take a look right here. And I'm going to use a nice, let's use this nice little orange. We know from our previous video that MB must be congruent to AB. However, I would ask you, let's see, what if I said, how does AM in fact compare to AB? Well, notice, what are we saying here? We're saying that AM is this half, and we're saying that AB is in fact the whole. So how do you do something like this when you have the half and the whole? Well, let's go ahead and write, if you will recall, let's go ahead and write our untrue statement. We could say AM is congruent to our whole AB, but we would know something. We would know that that's not totally accurate. It's not true. So what are we going to do here? Well, the question becomes, how many halves does it make to take a whole? And of course, you guys know this. It's 2. So guys, just remember that whenever you're given half of the segment, you have to multiply it by 2 to make the whole. Not only could we have this, we could also have 2 times our other half, MB. And of course, we could set that equal to the whole, once again, AB. All right. Also, also very intuitively, we could say that half of AB is AM or MB. That's not the focus of this lesson. Now let's take a look at where we could apply this in a different setting or a different situation. What if I give you this triangle here, and we see that this line here is DE, and let's call E the midpoint. Let's say that E is the midpoint of AC. Well, of course, we could say this. We could say that AE is congruent to EC. But once again, that's not our focus. My question to you is, how does AE compare to this whole thing, AC? And what I would hope you would say is this. I hope you would say that AE is congruent to the whole thing, which we know to be AC. And we just know that that is, in fact, flat out false. Remember, what's the question? How many halves does it take to make a whole? And hopefully, once again, you would say 2. Okay, what's one other statement we could say here? Well, of course, we could say 2 times AE is AC, but we could always, of course, choose the other half, in this case, EC. So we can say that 2 times EC is, in fact, congruent to the whole, once again, AC. Alright guys, I hope that these examples help. Let's move on to our next example. Okay, let's take a look at example 3. Now you might be thinking, Mr. Hastings, this problem's familiar. I did this in the previous section. Yes, but you were looking at the congruent angles. Now, what if I want to create a double ratio? In fact, let me write that down. A double ratio. Well, what's going to be the idea? The idea is going to be what we touched on in the previous section. We'll say that 2 times the half is of course congruent to the whole. So what would this look like in terms of here? Well, we could say that, we could say, I always choose the wrong blue here. We could say that 2 times, and what's our half? Well, let's pick BCD. Angle BCD is of course congruent to the whole thing, which of course we know is BCA. Angle BCA. Now if you wanted to create one more double angle ratio, what would it have to be? Well, hopefully you would pick this top part. Let's choose it in orange this time. Let's say ACD, and of course we can say angle ACD. We're going to multiply that whole thing by 2, would of course equal the whole thing, angle BCA. Okay, well there are 2 representations where our 2 times our halves will give us our whole. Let's move on to the next example. Okay, here in example 4, kind of like in our very first video, we have another example of an isosceles triangle. Now, how do we know it's isosceles? Well, of course, we know that we have our congruent sides. Now, what did we note in the previous example? Well, we know that there are base angles right here, base angles right there, and also one thing that we didn't really touch on because it wasn't necessary at the time is how about this guy, this third angle? What do we call this? Well, hopefully, many of y'all are mouthing the word vertex. That is our vertex angle, and I swear that's an R. So look, we have a vertex angle, and we have two base angles. Two base angles. Now, I want to kind of really break this down, because there's actually two ways you could think of it. Option A, you could think of it very generically. You could say, you know what, we have angle ABC, angle ABC, plus angle ACB, angle ACB, plus, and don't forget about this vertex angle here, which is BAC, angle BAC. And you know what we can say? We could say it all adds up to 180 degrees, because we know all three angles of a triangle add up to 180. However, we are not interested in that. We are interested in our double ratio. And what do we know about our base angles? Well, we know that these are in fact congruent base angles. So we're actually given two options here. If we are only given this angle right here and we don't know that one, what we can say is this. We can say 2 times angle ACB plus our vertex angle BAC is of course equal to 180 degrees. But wait a second, what if in fact we had this angle and we did not have that angle? How could we rewrite it now? Well, of course we could kind of say it the other way. We could say instead of angle AC, 2 times angle ACB, we could go ahead and pick our other base angle, this one, which in this case would be angle ABC. Alright, of course, that adds to our vertex angle, BAC, and this will, of course, add up to 180 degrees. So guys, here's what I'm saying. For our double ratio, if we know one of the base angles, we can simply multiply it by 2 and add it to the vertex angle. Alright, let's move on to our final example. Okay, here's our very final example. Now let's take a look here. We see our classic perpendicular bisector, but I want you to think of this actually in terms of angles, interestingly enough. And what do we know? Well, we know that on a straight line, that is 180 degrees. And so I would ask you, what do we also know? Well, we know that this little box right here, this little guy, indicates 90 degrees. Okay, and that of course indicates that we have 90 right there. So how could we write a double ratio for this problem? A double ratio, something times 2. Well, in this specific case, we can actually say this angle right here, we can say something like angle PSR is equal to 180 degrees. And we know that's false, but what can we multiply PSR by? Well, we can multiply PSR by 2. What if I wanted to create one more double ratio? Well, of course, I could do 2 times the other 90-degree angle, angle RSQ. And we know that that as well would equal 180 degrees. Alright guys, thank you for joining me on this trip for double ratios. I think these are the ones that you all struggle with the most. Good luck on the next section. And I'll see you guys in our next video.